So I'm going to start with this one. Okay, that's W20. And this is question paper 2-1. So we're going to start with this one, or we'll try and do two of the papers. First thing, shows the first ionization. Remember, this is W20 and question paper 2-1. So the first thing is you've got write an equation for the first ionization energy of Mg, includes state symbols. So you just have Mg losing electrons, and it should be gaseous. So it's going to form Mg1 plus, and 1 electron is lost. And you can write it both ways. You can write it as Mg minus 1 electron, or you can put the plus 1 electron on the other side. So the next one is, the next one is explain the observed trend in the first ionization energies down the group. So you have to explain this. So they're obviously they decrease down the group. That's probably going to be 1 mark. So what is the explanation? Why do they decrease down the group? क्या factors होंगे?
Sir, because ionic radius increases.
Okay, so one factor is that the ionic radius increases. What's the other one?
Shielding effect increases.
Okay, so we've got another one, which is shielding effect increasing. 1 second. So the number of shells increase, or the shielding effect increases. So that's why ionization energies decrease down the group. So at the end of the day, you're going to write a statement, which is, there's one factor that goes against that. What is that one factor? Okay, because of these two factors, it becomes easier to remove electrons, but there's one factor that actually...
Van der Waals forces.
The nuclear charge. When you move down the group, the number of protons are increasing. So you're going to write at the end that despite the fact protons are increasing, the attraction between the nucleus, you have to always write this statement at the end. The attraction of the nucleus and the outer electrons, it decreases. So it decreases down the group. Why? Because you've got a bigger ionic radius and you've got more shells. Or the end, you always have to write K. Despite the fact that protons are increasing, that's why the attraction of the nucleus and the outer electron decay. I mean, you should phrase it better. TK, I just wrote it in points. The other part is, and also remember, it's always it's actually even better to actually write in points. If the points are clear enough. I mean, the points that I've written, they're not very clear enough, but if you can write clear points, that it decreases down the group. Why? Because of these two factors. As ionic radius increases, or wo dusra bhi likh lo, theek hai? Or you can just write the whole in a paragraph form. But remember, points, writing answers in point form, that's better. Explain why the second ionization energy of B is higher than the first ionization energy of B. So why is it? What's the reason? Why is it? Why is it easier to remove the first electron and more difficult to remove the second electron? Like if it's already +1, why is the second ionization energy greater? Uska kya hoga?
Because in the first there is repulsion force, whereas in second it's not.
No, but what kind of repulsion? Like what's the difference between, if I draw the B atom, TK, if I draw the B atom, it's got, I think it has 4 protons. And 4 electrons, right? एक second, इसको सही कर लें. अच्छा, so it's got 4 electrons. So why is removing the first electron easier compared to removing the second electron? The first one, let's say the first one is this one. And then after removing the first one, you're removing the second one. So why is that? It's a 2-mark question.
So effective nuclear charge.
ठीक है नहीं effective nuclear charge
outer shell have less attraction, so that's why it's easier to lose the
हाँ
electrons.
but what's the reason for that? Yeah,
Because it's far away from the nucleus.
No, but both electrons have, I mean, they are far away. They're in the same shell. Both of them are going to be in S as well. Achha, what happens? Effective nuclear charge wali baat jo hai, that makes sense. I mean, what happens? It becomes harder to remove electrons from B that is neutral, and it becomes easier to remove electrons from B that is neutral, and harder to remove electrons from B that has a +1 charge. Not as such. Repulsion is not going to be a factor. The positive charge, it already has a positive charge now. So because of that, it kind of becomes harder to remove electrons. But let me explain this. Let's say the first electron is removed. And now the overall charge on this ion is +1. So mujhe explain karo. Obviously, the effective nuclear charge or the attraction for the electron is increasing, but why is it increasing? That's the point. Hamad, koi idea?
So we can add like
the number of protons is more than number of electrons.
Haan, theek hai, lekin what difference would that make? Like the electron is still, I mean, still 4 protons, right?
Mm-hmm.
So I mean, previously you had 4 protons as well. What difference is there existing between a B? I'll go through the points. The shielding is the same, right?
So shielding same as well.
The number of protons or the nuclear charge is the same as well, right? You had 4 protons, you still have 4 protons, right? Achha, what are the other factors?
So effective nuclear charge that increases.
The effective nuclear charge jo hai, wo to overall picture hai na ke wo to end
so
mein hota hai
the attraction of electrons to the nucleus.
But that is effective nuclear charge. I gave you point for that. That's 1 mark. Okay? That there is the attraction between the nucleus and the electron is obviously increasing. Okay? So the effective nuclear charge is increasing. That's why the ionization energy is going up. My question is, why is it increasing? Okay, what about distance? Is the distance the same or not?
The repulsion decreases, sir. So to wo pass ho jayega.
Let's talk about distance. What about distance? Remember, repulsion is not that big a factor. It only becomes a factor with your orbital level ke upar repulsion. That's only a factor when you go from group 5 to group 6, where you have spin pair repulsion. That factor is not that major a factor. Okay, is that clear? So wo jo repulsion wala part hai na, that can only be used in that scenario. Is that clear? Otherwise, don't write repulsion. Repulsion only happens when you're talking about sulfur having a lower ionization energy compared to oxygen. I said, what about distance? Is the distance of the second electron the same or is it different?
Same, sir.
Now, what happens when what happens when a positive ion is formed? Does the size of the ion become smaller or is it the same?
Smaller.
It always becomes smaller. Whenever you have the formation of a positive ion, jo ke pehla point tha, the effective nuclear charge is increasing. You've got 4 protons, but now it's attracting only 3 electrons. So the 3 electrons would be closer to the nucleus, right? Even with repulsion wala jo factor, you can include that, but the whole point is that whenever something forms a positive ion, and the same happens when something forms a negative ion, the opposite happens. When something forms a negative ion, the size of the ion becomes bigger. And similarly, when something forms a positive ion, you now have 4 protons, the same number of protons, but it is attracting fewer electrons. So those electrons are more strongly attracted to the nucleus. So in this case, distance decreases. Distance of the outer electron to the nucleus decreases. So that's going to be your second point. The first point was the effective nuclear charge, or you can describe it as, in other words, that the nucleus is more strongly attracted to the outer electron in B plus 1. But the main point would have been the reason why is it harder to remove the second electron, because it's closer to the nucleus. Is that point clear?
Yes, sir.
ठीक है, इसका point बना लो, because these questions, they're not typical questions. This one specifically, okay. I mean, the same could be applied for. I mean, the same thing can be. I mean, you can get a question about removing an electron from Cl or Cl minus 1. Both of them have the same number of electrons. Like, I don't want to draw the shells, but this is 288. They have the same number of protons. They have the same number of shells, shielding, etc. Everything is the same. Which one would have a lower ionization energy? Which one would be easy to remove electrons? Cl or Cl minus 1?
Cl minus 1.
Cl minus 1. It's going to be a bigger ion, because if you have more electrons, the electrons would repel each other. So the electrons would be slightly further away. When you form a negative ion, the size of the ion, it increases. Okay? So remember this. In this case, if you get a question similar to this, it's going to be, I mean, these are the two types of questions that you could get on this. So just remember, if everything is the same and something is forming an ion, positive ion, the size becomes smaller. When you have a negative ion, the size of the atom actually becomes bigger in size. So that would be your factor. ठीक है, एक factor तो वही होगा कि effective nuclear charge or the attraction decreases or increasing, and the other factor would be you'll talk about distance. ठीक है? Is this clear?
Sir.
हाँ जी.
सर मेरे दो सवाल थे सर, मैं आपसे कब ये समझ सकता हूँ सर? ये एक केसी का था सर, उसमें सर थोड़ा सा राउंडिंग इशू था सर.
अभी फौरन पूछो अगले क्वेश्चन से पहले. क्या?
सर ये सर अक्टूबर नवंबर 2014
W14 QP
paper 2 variant 3.
Just 1 second. अच्छा, which question?
सर ये एक केपी वाला सर क्वेश्चन 2 सर आखिरी सर मेरा 2.85 into 10 is power minus 13 आ रहा है.
ये कौन सा क्वेश्चन?
2.88 है सर.
अच्छा, ये वाला?
सर एक सेकंड.
हाँ, this one. Okay,
yes.
There's nitrogen and hydrogen. So what are you getting? You're getting?
So 2.85 into 10 is power minus 13.
Pisha, what's the answer?
2.88.
So let's quickly do this. I mean, I think it's what is the reaction? Did they? It's N2 plus 3H2. This one is N2 plus 3H2, and it's in equilibrium with 2NH3, right? And your initial moles are what? Initial are 2 of these and 3 of these, they react and they are left to reach equilibrium. So there's 0 of that. And your equilibrium moles are 1.6 moles of ammonia are present at equilibrium. So that means you had 0 initially and 1.6 got produced. So if 1.6 are getting produced, that means 1.6 got produced. So use ratios. How much H2 would react? 2:3. If 1.6 are getting produced,
2.4.
2.4 moles of H2 must have reacted, right? And how much? 0.8 moles of N2 must have reacted, right? Mute kar lo. As a 0.8 moles of this would have reacted according to the ratio. It's to produce 1.6. So out of 3, you're left with how much? You're left with 0.6 moles. And out of 2, you're left with 1.2. Are these the same values you're getting, right?
Yes, sir.
That's okay. The next part is you have to find, if you want to find Kp, you would have to find the partial pressure. So how do you find partial pressure? It's 1.2 divided by the whole thing, which is how many moles? 1.2 plus 1.6 plus 0.6. What do you get?
3.4.
So it's 3.4. And that's times 2 into 10 to the power 7 pascals. Okay? This one would be 0.6 divided by 3.4 into 10 is per 7. 2 into 10 per 7. And this one is 1.6 over 3.4 times 2 times 10 past 7, right? And the next thing is it's going to be NH3 squared, right? So, I mean, this thing squared divided by H2, that's going to be cubed. And this is going to be power 1, right? So try and solve this. What do you get for this? I said, make sure if you round things at every step, there's going to be a rounding error.
Yes, sir, मैं हर step में round करा था.
हाँ, मतलब make sure
लेकिन आपने कहा था कैलकुलेटर में larger value use करनी है, पेपर पे बेशक rounded off लेकिन सर उससे सर मेरा आंसर 2 पॉइंट ज़्यादा.
ठीक है, just be careful about the rounding error because you're going to lose 1 mark for this because if your value deviates from the one that's given in the market scheme. So make sure if you're supposed to write this value, I mean, you should round it off till the appropriate significant figures. In this case, the appropriate significant figure is 3 significant figures. Okay? I mean, your answer should, I mean, whatever you write on paper, it should not have an accuracy greater than 3 significant figures. But the other part is keep the answer as accurate as possible on your calculator. Don't round off things on your calculator. So, ab sahi aa rahi hai?
Sir, like, sir, calculator में 9411764 आ रहा है. सर, अब मैं इसको 941000 करके
लिख रहा है.
9411764.
11764.
9411764.706.
So ठीक है, but your answer cannot be more accurate than 3 significant figures.
Calculator वाली value.
So it's going to be 941
so
and then.
So ये NH3 के अकेले है, so this is not the KP overall.
So नहीं, it's on the अच्छा ठीक है. Like when you're writing it on paper, I mean, write it up till 3 significant figures. But you're going for the KP value. Do everything in one step on your calculator. Like try and solve the whole KP value. Okay? We're not doing topic wise. I'm just in between. I'm solving questions as well. Okay? As I say, if Fatma ka question is
so मेरा एक और भी था सर. I have a question.
So एक simple math का कर लेते हैं. That's what's the other one?
So ये infrared का था. So October, November.
Sir, before you move on, can I ask a question?
Yes.
Sir, अगर इधर हमने mole ratio लेनी हो, what will be the mole ratio? जो balanced equation में ratio है या जो equilibrium पे moles की ratio है?
नहीं देखो, this is not the ratio. ठीक है, this is not. I mean, any number of moles could be present at the equilibrium. ठीक है, there's no. I mean, these ratio. I mean, they don't have a ratio. Okay, the initial moles, you can put any amount of moles in the container. That won't have a ratio as well. The ratio, I mean, this ratio over here only applies to the reaction, if there's a reaction happening. And there is a reaction happening, which is, so you're gonna apply the ratio to the reaction that is taking place. So you had 0, and now you have 1.6. So that means 1.6 got produced, right? So you're going to apply the ratio to this 1.6 that it's getting produced. There's an extra 1.6 getting produced, right? So if you want to produce 1.6 according to the ratio 2:3, 2.4 must have reacted, right? And to produce 1.6 according to the ratio 0.8 must have reacted, right? Is that clear?
Yes.
So ये जो बीच वाला part है ना, I'm keeping that for reacted and produced, like whatever is happening. So the ratio only applies to the things that are actually taking part in the reaction. सही है?
But
So
sir,
end
if
में
you have to find the partial pressure, for example, at equilibrium, then
so you're going to use the equilibrium moles, na? Okay, how do you find partial pressure? What's the formula of partial pressure? That's partial plus mole fraction multiplied by the total pressure. So the mole fraction is at the end of the day at equilibrium. Okay, this is equilibrium. At the end of the day, at equilibrium, you've got 1.2 moles of this, 0.6 of this, and 1.6 of this. So that's your total moles. And
okay.
so the mole fraction is 1.2 out of the total, which is 3.4. See?
Wait, sir, how did you get 1.2 and 0.6?
How did I get?
1.2 and 0.6.
See, is this clear that the question stated that initially you had 0 moles, right? Of NH3. I mean, they didn't mention any NH3 in the container. So you had 0 moles. And then it stated that at equilibrium, it contained 1.6. So that means 1.6 got produced, right? Is that clear?
Yeah.
So according to the equation, if you want to produce 1.6, 2:3. So if you want to produce 1.6, how much H2 must have reacted? It must be 2.4 moles, right? To produce 1.6, 2:3. Is that clear as well? I mean, what's 2:3? 1.6 getting produced. So 2.4 must have reacted, right?
Yeah.
And according to the ratio, if you've got 2 and it's 2:1. So if you want to produce 1.6, according to the ratio, 0.8 must have reacted, right?
Yeah.
So that means out of the 3 moles that you had initially put in the container, 2.4 are gone because they've reacted. They've reacted and they've produced 1.6. So 2.4 are gone. So out of the 3 moles, how much is left? That's 0.6. Is that clear?
Yeah. Oh, okay.
And initially you had 2 moles of N2 that were put in the container, and to produce 1.6, 0.8 must have reacted. So you remove 0.8, you're left with 1.2. So that's the final moles that you have at equilibrium.
Oh, okay. Thank you. Yeah, I get it.
So Ahmad, दूसरा question क्या है?
October, November 2018, paper 2, variant 1. Last question.
W18.
Paper 2, variant 1.
अच्छा, कौन सा which question?
Last.
अच्छा, this one?
Yes.
अच्छा, this one is you've got when glycolic acid is heated in the presence of what's glycolic acid? It's this one. That is glycolic acid. So it's basically an alcohol with a carboxylic acid. So I mean, if I just draw it over here, I mean, actually, this is they gave you over here. So you got glycolic acid. It's on one side it's got a carboxylic acid. On the other side you got an alcohol, right? I said this is a bit of a guess. I mean, it's kind of straightforward. 2 molecules of glycolic acid are reacting with what? With each other, right? You didn't add anything. So 2 molecules of glycolic acid are reacting with each other. So if I have, so what can be produced? You got a carboxylic acid, you got an alcohol. So what do carboxylic acid and alcohols react together to form?
Ester.
So they're going to form esters. So you got a carboxylic acid, and let's make this the OH, and you got another molecule, and that is also a let's put an alcohol next to it, and the double bond O and OH. So what happens? The OH is lost, the H is lost, right? And carboxylic acid OH is gone, the H is gone, and they would end up forming ester. You don't even need the infrared spectroscopy for this. You can just guess. That's the only reaction you know of. So they would end up forming an ester, and I think there's going to be one O left over here as well. ठीक है, the water molecule.
जब आपस में react करते हैं तो फिर cyclic structure बनता है ना सर?
हाँ, because So maybe let's assume that it's not a cyclic structure. Okay, that's another possibility. Maybe they're not forming a cyclic structure. Okay, so maybe two molecules are just reacting end to end. So let's assume that we're not sure whether it's a cyclic structure or not. So let's say there is an alcohol. Okay, and I have a carboxylic acid. So let's assume it's not a cyclic structure. The OH is lost, the H is lost. Same thing as the one, but not a cyclic structure. So the OH is gone and the water molecule is gone. And they would form.
Sir, लेकिन marking scheme में सर एक mark उन्होंने कहा है cyclic का. Yes.
नहीं वो मैं बताता हूँ. I'll explain. अच्छा, so I've got two possibilities now. One of them is this. One of them is this. One of them is cyclic. The other one. Now at the moment, let's assume we don't know which one is the right one. That's why they gave us the infrared spectroscopy as well. First thing, match the formula of Y. Does that eliminate one of them, C4H4O4? It doesn't. I mean, this is not possible because what are they saying? They're saying that there are two water molecules that are being produced, right? So over here, how many water molecules got produced? Only one, right? Is that clear? So one way to eliminate this one is this way. Okay, they were saying two water molecules getting produced, but we're getting only. Over here, you got two water molecules getting produced. You got an ester over here, and you got an ester between these groups over here as well. So that is one way of figuring this out. The other way you could have eliminated is by looking at the infrared spectroscopy, because this one has an alcohol OH. And if you look at the data booklet, the alcohol OH has an infrared spread. I mean, it vibrates at these wave numbers that something above 3200. I mean, you can open the data booklet. The OH from an alcohol has a peak at greater than 3200. You're not getting anything over here. And this one has a carboxylic acid OH as well. So the carboxylic acid OH has a peak that is around 3000, but it's strong and very broad. So there are many ways of eliminating this one. You could have matched this one, or you could have just looked at that there are two water molecules getting produced.
Same, sir. Thank you very much, sir.
Sir, but two molecules of glycolic acid are also reacting.
वो तो दोनों cases
won't
में. In both cases. The question क्या?
Sir, you're saying is how to eliminate that? We have to go with the cyclic one, because sir कि ऊपर उन्होंने mention किया हुआ कि दो glycosylic molecules are reacting.
हाँ, वो इसमें भी react कर रहे थे, लेकिन इसके अंदर there were two water molecules getting produced, right? One over here and one over here. But carboxylic acid OH was lost. But over here there were two water molecules getting produced, right? So that's how I assumed that it's going to be a cyclic structure. Okay, if you react them end to end, so in the middle they would just lose one water molecule. So that means this end, the alcohol end and the carboxylic acid end, they would also react with each other. So it will form a cyclic structure, because that is the only way another water molecule is going to be produced. Clear?
Yes, sir.
चले और क्या क्वेश्चन है महात्मा हो गया? अच्छा वो किसी और का था. Just 1 second. So there was a question on. Just a second. Summer 1822. Nee, Fatma, are you there? Can you tell me what the question is? So और तो कोई question नहीं किसी का. मैं फिर वही कर रहा हूँ.
Sir, May June 18 paper 2 question 2.
एक second. Summer 1822. I said this one now. Okay, question number 2. The whole
Sir,
question.
question 2, part B.
Part B.
Ji, sir.
He's asking
Sir,
for
D,
the
D.
D. I said D is I said it's a Mohs question. You've got Mohs salt, which is hydrated form of ammonium iron 2 sulfate. So whatever that is, the formula is given. I said so. X represents the number of moles of water in 1 mole of the salt. So yeah, I think the question is about it's about finding what X is. To get this one. Now, a student wanted to determine the value of X. 0.78 grams of the hydrated salt. So this thing, the whole thing was 0.784 grams. Make sure draw some sort of sketch for this. Now that's dissolved in water and the solution was acidified. So you got this thing, the solution was acidified. All of the solution was titrated with what? With 0.02 mole per dm cube of potassium magnate 7. So you got a solution at the bottom. And remember, the solution is this thing. And it required potassium magnate, KMnO4 was added from the top. And you can figure out the moles of KMnO4 that were added. It's 0.2 mole per dm cube of 20 cm cube. So how many moles is this?
4 into 10 raised to power minus 4.
So you're adding 4 times 10 power minus 4 moles. I said now this Mohs salt has many different ions. It's got iron ions, it's got sulfate, it's got ammonium ions. But over here they're saying that that it only was required for complete reaction with the Fe2 plus ions. So there's an Fe2 plus ion over here. So if MnO4 minus 1 is 4 times 10 power minus 4 moles, that's the first thing, Peleto, you have to balance the equation without. So you have to balance the equation. What is the oxidation state of Mn? That's plus 7, right? What's the oxidation state of Mn over here? That's plus 2. So that means it's a gain of how many electrons? That's a gain of 5 electrons. And Fe is plus 2 and it goes to plus 3. So that's a loss of 1 electron. So who do I multiply by 5 so that the electrons gain and loss are equal? Fe ko karna hai na? Okay, so there should be, to make the electrons gain and loss equal, I'll just multiply Fe by 5. Oh, that's it. Okay, the Mn, you just have to keep 1 Mn. And then the number of electrons gain and loss would be equal. And then you can balance the rest of the atoms. You got 4 oxygens, so there should be 4 H2Os. And you got 8 hydrogens, so there should be 8 hydrogens, which are plus 1. So yeah, so we've balanced the equation. Now the other part is you've already figured out the moles of MnO4 minus 1. That's 4 times 10 raised to power minus 4 moles, right? So how many moles of Fe2 plus do you have? That's 1:5. So multiply this by 5. What do you get?
2 into 10 raised to power minus 3.
So you're getting 2 times 10 to the power minus 3 moles of Fe2 plus. So that kind of pretty much sums up the question. Where are you getting all this Fe2 plus? All this Fe2 plus, you're getting it from the Mohs salt. So what is the ratio of the Mohs salt and how much Fe2 plus is produced? But the other clear enough, it's you dissolve this thing and this thing has 2 into 10 to the minus 3 moles of Fe2 plus. Now, where did you get all the Fe2 plus in this solution? You got all the Fe2 plus when you dissolved this thing in water, right? So when you dissolve this thing in water, how much Fe2 plus ions are produced? Only 1 would be produced, right? Like it's going to be 1:1. Like if you dissolve 1 molecule of the Mohs salt, it's going to produce exactly 1 Fe2 plus because it only has 1 Fe2 plus. So if your solution has 2 times 10 power minus 3 moles of Fe2 plus, so the amount of Mohs salt would also be 2 into 10 power minus 3 moles as well. Is that clear? Okay, all the Fe2 plus is coming from the Mohs salt and the ratio of the Fe2 plus ions to Mohs salt is 1:1. because if you dissolve one of this, it produces exactly one Fe2 plus. So if you
So
got
what if
two,
there were 2 Fe?
हाँ फिर
What
रेशियो
if
डिफरेंट
there were
होता
2?
हाँ अगर यहाँ पे Fe2 लिखा होता ना, then there would be 2 Fe2 plus ions being produced. So the ratio would be, I mean, let's assume there was the Mohr salt had this formula. If it was, let's say, Fe2SO4. So in that case, the ratio would have been 1 Mohr salt would produce 2 Fe2 plus ions. So if you had 2 into 10 to the minus 3 moles of Fe2 plus, the amount of Mohr salt would be 1 times 10 to the minus 3. It's going to be 2:1. One of them would produce 2 Fe2 plus. But in this case, it's exactly 1:1. Okay, 1 Mohr salt produces exactly 1 Fe2 plus. So 2 into 10 to the minus 3 moles, if you have that many moles of Fe2 plus in this solution, you have exactly the same moles of the Mohr salt as well. Is that clear?
Yes, sir.
So the next part is you've got, so you figured out the moles of this thing. So the next part is calculate the relative formula mass of this thing. So you can find that you have the moles and you also have the mass as well. That's 0.784 grams. ठीक है वो शुरू में ही दिया हुआ था. They gave you the mass as well. So moles is equal to mass divided by mr. So the mr or the formula mass would be mass over moles. So it's just going to be 2 into 10 is per, that's mass 0.784. So it's going to be 0.784 divided by 2 times 10 per minus 3. And you solve that, you'll find the MR. And the next part would be easy. When you have the MR, all you have to do is figure out what X is. So you'll add all of them up and find what is the MR that we are getting?
392.
Let's take 392. So just find out Fe is 55.8, 32.1, 16 into 4. This is 18 into 2. And then find out what would this be. So you'll just find what X is. Okay, is that clear?
Yes, sir. Thank you.
It's an ortho quick question. We will continue with the paper. So ये वाला फिर से. Okay, we've got phosphorus, sulfur, and chlorine can all react with oxygen to form oxides, and phosphorus reacts with oxygen to form phosphorus 5 oxide. So write the equation, that's easy, P plus O2. What is the formula of phosphorus oxide when it reacts with excess oxygen? Okay, when it reacts with excess oxygen, what's the formula of phosphorus oxides?
P4O10.
Okay, just remember you have two P4O10, you also have P4O6 as well. But P4O6 will not be written over here because you're reacting with excess oxygen. So it's going to form the oxide with the higher oxidation state. Describe the reaction of phosphorus oxide with water. So first thing, what happens when P4O10 mixes with water?
Phosphoric acid.
The concept of phosphorus or phosphoric acid?
Phosphoric.
Okay, that's going to be phosphoric acid, that's H3PO4. Remember, this other one forms a phosphorus oxide. So it's going to form an acidic, it's going to form an acidic solution. But you have to describe this. To describe, they're not talking really about observation, so that kind of makes it vague. But how do you describe this reaction? What is going to happen? What is the state of P4O10? Like, we're going to go for observations because description of the reaction is, I guess that is the observation. So what is
a vigorous reaction?
It's a vigorous reaction. What is the state of P4O10?
Solid.
That's a solid. So what will happen? The solid would disappear because phosphoric acid is an acid that is also. So the solid P4O10 would disappear. I mean, that should be enough.
Can you say the solution becomes acidic?
You can obviously say that. an acidic solution is formed.
Right.
So that should kind of be it. Because that's a 2-mark question. So vigorous reaction, solid P4O10 disappears, and it's forming an acidic solution. State the structure and bonding of phosphorus 5 oxide. Phosphorus and oxygen. Is this covalent or ionic? I mean, first thing, together it's bonding, it's non-metals, right? So it's covalent. The structure, is this what type of covalent structure is this?
Simple? Simple.
Together that's a simple covalent structure or simple molecular. The bonding is covalent. The 2 most common oxides of sulfur are SO2 and first, what is meant by the Bronsted-Lowry acid? That's a proton donor. Weak means it doesn't fully ionize. Those are the 2 words you're going to use, or partially or weakly ionizes. Write the equation for the reaction of SO2. What kind of acid would be formed when SO2 reacts with water?
Sulfurous.
It's going to form H2SO3. You can remember this. SO3 forms H2SO4. You've got another reaction. Part number 3 state the role of NO2 in this 2-stage process. What is NO2 doing over here?
Catalyst.
And what type of catalyst?
Homogeneous.
Okay, that's homogeneous because all of them are gases. So NO2 remains unchanged. It takes part in the reaction, but remains unchanged. So this is a homogeneous catalyst because the state of the catalyst is the same as the reactants. As a state, the type of reaction in 1, what is this reaction? What is the type of reaction?
Decomposition.
But the better one would be that's thermal decomposition. The next part is you've got to calculate the enthalpy. Use the data to calculate the enthalpy change for reaction number 2. So the enthalpy of formation of calcium oxide is given, of sulfur dioxide is also given. CaSO4 enthalpy of formation is also provided. And oxygen, what's the enthalpy of formation of oxygen?
0.
The oxygen is 0. So what formula would you use to figure out the enthalpy of, what is
Product
the formula?
minus reaction.
Okay, that's product minus reaction. Enthalpy of formation of products minus, be careful with the moles and the signs. Okay, try and do this on your calculator, practice this, even though it's a simple calculation, but make sure the number 1 source of error is just calculated. You'll just mess things up on the calculator. So the product in this case is minus 1434. Put large brackets around it, minus the reactants, which are calcium oxide, that's minus 635. There's only 1 SO2, so that's minus 297, and O2 is 0. So this side would become all positive. So what is the answer that we are getting for this?
Minus 502.
Here, units kilojoules per mole. So make sure when you're doing enthalpy change calculations, remember this as well. There's a very tiny, people mess this up as well. When you use Q is equal to MC delta T, although that's not required in this question, but whenever you use Q is equal to MC delta T, this value is in joules. Remember that. So if the answer has things written in kilojoules, make sure you do the conversion. Like once you use Q is equal to MC delta T, make sure you convert that into kilojoules by dividing by 1000. Keep this in mind as well. Now draw a dot and cross diagram for ClO2 showing outer electrons only. So oxygen and Cl, that's easy. Cl will share 1 electron. Oxygen will have, these should be crosses. So oxygen is in group 6, so it forms the 2 bonds. And so what's the oxidation state of Cl over here?
0.
What's the oxidation state of Cl over here as well?
-2.
Nay.
Sorry,
+4.
-4.
+4.
+4. Well, oxygen is -2, so that's
Oh, right.
-2 minus.
Yeah.
And what is Cl over here? That's
-1.
-1.
so that's -1. So you have this reaction. State and explain the effect of on the yield of Cl2O6 when the experiment on this one, Cl2O6. When the experiment is carried out at 1000 kelvins and 100 kilopascals. पहले क्या temperature था? That was sorry, it's written over here. So what they did was the pressure is kept the same, the temperature is increased. So when you increase temperature, what happens? Which reaction is favored?
Endothermic.
So in this case, it's going to be what?
The reaction will move
Backward.
towards left side.
Okay, so backward
The
or
yield will decrease.
okay, so this amount, this would be less produced. I mean, the amount would decrease, the yield would decrease. Okay, right, all that. This one is now what they're doing is it's the temperature is the same, the pressure is increased. So when you take the reaction to higher pressure, which side is favored?
Forward reaction is favored.
नहीं पहले तो उसको steps में लिखो. Less gas mole side is favored, right? And then you're going to mole side is favored, and then you're going to say that which one is the less gas moles side. Why is it the forward one? Sorry, 3 moles. That is the less gas mole side.
Yeah. Forward reaction.
Okay. But you got 3 moles and you got 4 moles on the left side. So that is the forward side. Okay, so answer this properly that if it's increased temperature, endothermic is going to be favored, and the endothermic is the backward reaction, or the equilibrium position shifts to the left, or the reactant side is favored. Okay, and the yield would decrease. Over here, the yield would increase. The high pressure, less gas mole side is favored, and which is the forward side. So reaction moves forward, or equilibrium shifts to the right, and yield would increase. So now we have element E, which is a period 5 element. So element E reacts with, so now you've only studied period 3. Here मैं बता दूं, it's 21. This is winter 20, paper 2-1. Achha, this one. Okay, just a second. Achha, this one. You've got, remember, elements in the period, and let me open the the assumption is that the third period element, their properties would represent the fourth period element. I mean, within the same group, the properties kind of remain the same. Like if you have carbon, then silicon's property would be similar. Germanium's property would be similar. So within a group, although it's not going to be exactly similar, but the assumption is you only know period 3. So the properties would kind of be similar. As paper, a second. Where is, as anyway, so E reacts with oxygen to form an insoluble white oxide that has a high, I mean, it's got a high melting point, and it's got an insoluble oxide, white oxide. As first tell me, which period 3 element does it resemble?
Magnesium.
So it represents magnesium oxide because it's an insoluble oxide. Plus, it's got a very high melting point as well. Any other element from period 3?
Aluminium.
Even aluminum oxide is the same. And you can also talk about SiO2 as well, because The only problem with SiO2 is that it's probably not white, or exactly white. Aluminium oxide and magnesium oxide are definitely white. Then it says that the oxide of E conducts electricity only when liquid, when you melt it. So we can rule out SiO2 because that's covalent, right? But aluminium oxide and at the same time magnesium oxide, they will conduct electricity, right? Because when you melt them. Is that clear? Because why would they conduct electricity when you melt them?
They have free electrons to move. Because they have free electrons.
No, not free electrons, because they're free moving ions. They're both ionic compounds. In ionic compounds, the electricity is conducted. Why? Because it's a bunch of ions which are sticking to each other. They're attracted to each other, but when you melt them, they start to move around. That's the next one. E also reacts readily with Cl2 to form a white solid that reacts exothermically with water. उसका मैं एक आंसर कर दूं. हाँ ठीक है, that's SiO2 is actually white. The reason I actually excluded SiO2 was it's why did I, because it's not going to conduct electricity, that's why. As E also reacts readily with Cl2 to form a white solid, and that reacts exothermically with water. So I've got two white solids now. One is MgCl2 and the other one is AlCl3. Okay, so again, I've got only these two options left. So they're chlorides now. The reaction with Cl2, they would form a white solid. Group 1, 2, 3, they always form white solids. Who's going to react exothermically with water? And the resulting. Remember this, that let me just go through chlorides and oxides once more. Okay, 1 second. Aluminium chloride reacts with water to form fumes of HCl. Magnesium chloride doesn't really do much. It only has a very slight hydrolysis. Just a second. Okay, खुल गया इसमें. So I have this one. Okay, that's right in front of you. So remember this. NaCl absolutely has no reaction with water. It's white. MgCl2, very slight hydrolysis. It's almost neutral. The hydrolysis is very, very slight. The pH is almost 6.5. Okay. The reason I'm not considering sodium oxide is that they said it's an insoluble oxide. Sodium is very soluble. Aluminium chloride would also have a vigorous reaction. Fumes of HCl would be produced. Si to वैसे निकल गया. We've already removed Si. So it's these two, and you can remove MgCl2 from this. Is that clear as well? We can safely remove MgCl2 because yes. it's not going to have that reacts exothermically with water. It's going to have almost no reaction with water. I just suggest the type of bonding of the chloride of E. Just a second, मैं पहले वो थोड़ा सा explain कर दूं दोबारा से. First thing, I'm just ignoring period 5. I'm just focusing on period 3. Starting with the first thing, it's an insoluble white oxide. So if it's an insoluble white oxide and it's insoluble, okay, so sodium can't be it. Okay, it can't be sodium. The next part is that they said that it conducts electricity when it's liquid. So only ionic compounds conduct electricity. So you're only left with MgO and Al2O3 because it's going to be ionic. Okay, this statement is referring to something that is ionic. Because you've only got two types of oxides. It's either a covalent oxide or an ionic oxide. So silicon is out of the question now. Okay, sodium was out of the question because it's not insoluble. Then it reacts with Cl2. You're only left with Mg and Al. So you either have magnesium chloride or you have AlCl3. So you have Mg ions and AlCl3. Now the thing with Mg ions is that they have almost no, the magnesium chloride almost has no hydrolysis. while aluminum chloride has a pretty strong hydrolysis. अच्छा वो एक second ये मैं बता दूं कि this is the reaction of aluminum chloride that you're going to write. ठीक है, this is the detailed reaction that it forms it first forms a complex ion, it has a vigorous reaction, and then that complex ion turns into an aluminum hydroxide precipitate. And the H+1 NCl ions that are released, they end up forming fumes of HCl gas. So the overall reaction is this one. The overall reaction is this one, AlCl3 reacting with water. The overall reaction is it's going to form aluminum hydroxide and HCl. But the more detailed version that they're looking for now is this one, that it first becomes aqueous, forms a complex ion, surrounds itself by water molecules like the one that's shown over here, and then the water gets hydrolyzed. The H+1 ions are repelled by the aluminum ion, greater charge density, and aluminum hydroxide is formed. So coming back to the question, okay, we've kind of singled it out to aluminum. And remember, aluminum isn't even in period 5, it's in period 3. So just suggest the type of bonding by the oxide of Fe. So you're going to say it's ionic. And what's the main reason for that? What are the properties of ionic? What is the evidence that it's ionic? So you're going to write or explain that it's got a high melting point, plus it conducts electricity when liquid, which means that it has free moving ions. Suggest the type of bonding by the chloride of E. Explain your answer. Now, since we have figured that out to this thing, AlCl3, what type of bonding does AlCl3 have?
Ionic, right?
The AlCl3, remember, is a covalent molecule. Okay, although aluminum oxide is
covalent.
No, it is covalent. I mean, AlCl3. And one thing else, because you might be doing past paper practice, but there's not a lot of Pauling scale. Okay, I'll bring in the Pauling scale, which is in the latest data booklet. How would you know that it's covalent or ionic? So now you have in the data booklet, I mean, it would be printed with the question. Not in this one, just a second. Where's the new syllabus? This one.
On the scale, how big is the difference supposed to be so that it's ionic?
1.7, greater than 1.7. So you've got aluminium, which is 1.5, and you've got Cl. So the difference in electronegativity is 1.5. So if it's less than 1.7, that's going to be covalent. And because there is hydrolysis happening, covalent molecules undergo hydrolysis with water. The ionic ones, the ones that are more ionic, make sure you remember this as well. The ones that are more ionic, they don't react with water. Like NaCl, it doesn't really attract water that much because the sodium ion has a very weak attraction for electrons. It's a very electropositive ion. It always likes to lose electrons. So it's not really interested in the lone pairs of water. But when you go for aluminum ions, the bonding becomes increasingly covalent. Aluminum ions, because of the greater number of protons, has a very strong attraction for electrons. So it starts attracting the electrons from the water molecule, which is why you have hydrolysis. You have a covalent molecule. They start, so when does hydrolysis happen? For ionic compounds or more ionic compounds, there is no hydrolysis. But when the bonding becomes increasingly covalent, there is a strong hydrolysis that's happening. They would react with water because covalent molecules or atoms that form covalent molecules are the ones that are electronegative. They like to gain electrons. So what they'll do is that they will attract electrons from water and they would react with it. Sodium will not do that. Sodium ions, they're extremely electropositive. They don't like to gain electrons. So they will not be interested in the electrons from the water molecule. So the evidence that it's a covalent molecule is, from the data that's given over here, is that it reacts exothermically with water. It hydrolyzes very quickly. So that indicates that it is covalent. Is that clear?
Yes.
So more hydrolysis happening, that's covalent. Something that is just mixing with water and dissociating into ions, that's most likely ionic. That's the next one. Okay, but remember this point. I mean, this one is an important point. Probably not written over here, but if the bonding becomes increasingly covalent, there's going to be more and more vigorous hydrolysis. And if it's ionic, like NaCl, then there will not be any hydrolysis. That's the next one. Quickly, we've got LiAlH4. Clear? Pista clear tha? Do you have questions about that?
It's clear.
As the next one, the reducing. But again, coming back to this question, make sure although it's not that big a question, but make sure the reasoning is crystal clear. Make sure you connect. I mean, when you get questions like these are kind of vaguer questions. Like the answers are. I mean, you're not always sure what to write in the answers. So make sure you use the data that's given very, very carefully, and make sure your reasoning is correct. I mean, you should know what ionic is. How do you know it's ionic? It's got high melting point. Even further explain that why do ionic compounds have high melting point? Because they've got a giant ionic lattice, and the positive and negative ions, they attract each other very, very strongly. Why do they conduct electricity? Because they've got free moving ions. I mean, go through the structures. And go through the reasoning as well. Ionic have certain properties. Why do they have those properties? Covalent have certain properties. I mean, the main properties of covalent molecules are that they have low melting points because it's a simple molecular structure where you have tiny molecules and they are attracted to each other with weak intermolecular forces. But over here, the main reasoning was that it's covalent because there's hydrolysis that's happening. And covalent molecules, they never conduct electricity. There's only a few giant covalent structures that do. So anyways, moving to the next question, we've got like in PIS, I'm just stressing you have to go through the structures. It's very important, especially when you get an inorganic question. Now, the reducing agent LiLH4 can be synthesized by reacting aluminum chloride with lithium hydride, LiH. At 200 degrees centigrade, aluminum chloride exists as, draw the structure of Al2Cl6. So that is the coordinate bonds that are formed. You've got an AlCl3 molecule, and you have another AlCl3 molecule. So the Cl has lots of lone pairs, and aluminum has an incomplete octet, so they would join together. And they would end up forming a dative bond. State the bond angle in AlCl3. What's the bond angle in AlCl3 when you just have 3 bonds?
120.
Okay, that's going to be 120. State the electron. I mean, that's easy. State the electronic configuration of these two ions. So not really sure what electronic configuration are they looking for. I'm just going to go with the 1s2, 2s2 one, the most detailed one. Okay, when in doubt, I mean, give the most detailed version of the answer. So Li plus one, I think that's it's got 3 electrons. So now it's got 2 electrons. So that's going to be 1s2. And H minus 1 had 1 electron, but now it's going to be 1s2 as well, right? So LiAlH4 decomposes slowly. And when it decomposes slowly, describe metallic bonding. So the question is about metallic bonding. How would you describe metallic bonding? What words would you use?
Electrostatic force of attraction between the positive ions and the sea of delocalized electrons.
Okay. Again, we'll probably get 1 mark for that, but because this is a 1 mark question. But remember, again, go through the structures. Metallic bonding. How do you describe metallic bonding in O levels? It's a giant metallic lattice. Okay, so it's a lattice of what? Lattice of positive metal ions in a sea of mobile electrons. And because you have to describe the whole scenario first, and then then it comes that there's an electrostatic force of attraction between the positive metal ions and the sea of mobile electrons. Okay. Usually when they talk about metallic bonding, they're not really talking about the bonding itself specifically, but the whole structure. Okay. Whenever you get a question about metallic bonding, you have to describe the whole structure. And then you also have to write the end part, like why are they attracted to each other? Because the positive ions and the mobile electrons, they have an electrostatic force of attraction. As a next one, LiAlH4 cannot be used in aqueous solution because it reacts with water to produce LiOH, H2, and a white precipitate, which is soluble in excess sodium hydroxide. Now this thing, make sure go through because you don't have practicals anymore. I mean, most of you have opted out. But make sure remember the test for the practical ions as well, which is, just a second, this one. Make sure you know what the test for practical, what the lab tests are for these ions. So aluminium has a white precipitate that is very, very soluble in excess, NaOH, and it's insoluble in NH3. So if I go back to the question, he's saying there's a white precipitate which is soluble in excess sodium hydroxide. That's the precipitate of aluminium. So identify the white precipitate which is soluble in excess sodium hydroxide. That is aluminium hydroxide. Okay, that's the solid precipitate that dissolves. Because that's the only thing that's possible when this thing reacts with water. So what will aluminium form? That would form probably hydroxide. Now, two students try to prepare this molecule over here, and both students oxidize butane 1,2-diol to form P in reaction 1, this thing. So that is reaction 1. It says one student then reduces P using LiLH4. The other one does it using NaBH4. State the reagents and conditions for reaction number 1. So what is reaction number 1? I mean, they've written over here, that's oxidation. So what are the reagents? You've got a primary alcohol and a secondary alcohol. How do you oxidize them?
Acidified KMNO4.
KMNO4?
No, don't write KMNO4. Remember this. I previously told you as well. I mean, KMNO4 is fine. There's nothing wrong with that. The only thing is KMNO4 is not usually written in the marking scheme. And even if you have some idea of the lab conditions, KMNO4 is a slightly stronger oxidizing agent. So even though KMNO4 is fine, there's nothing wrong with it. I mean, often the Cambridge ones, they also use KMNO4 in the question. Does the same thing. But I've put that in brackets over here in the chart, but just avoid it. Okay, don't write it. If they ask you, don't write it. Write K2Cr2O7 always. So in this case, we're going to go with, where's the paper? So we're going to go with, the reagent is going to be K2Cr2O7. What are the conditions?
Acidified and heat under reflux.
Okay, so acidified and heat with reflux. Okay, and try to write the whole thing, heat with reflux or heat under reflux instead of just reflux. And why reflux? Because you had to do the whole oxidation. Otherwise, primary alcohols will turn into aldehydes and will not react completely and will not form carboxylic acid. As agla part, only one of the students successfully prepares 2-hydroxybutanoic acid. So which one will prepare 2-hydroxybutanoic acid? What is 2-hydroxybutanoic butanoic acid. That is, what is butanoic? That's 1, 2, 3, 4. That's but. What is butanoic acid? That's double bond O, OH. And what is 2-hydroxy? On the second one, there is OH, right? So that is 2-hydroxy butanoic acid. So he's saying only one of them is going to prepare 2-hydroxy butanoic acid. Who's going to be, is it going to be Q or is it going to be R?
Q.
Q
Yeah.
will not, it's going to be R. Q will not do that. And the reason for that is, okay, remember that a carboxylic acid, if you use LiAlH4, the carboxylic acid will get reduced to an aldehyde. And if you don't take out the aldehyde, it will get further reduced to an alcohol. So, and LiAlH4 will also, LiAlH4 will do any type of reduction. It will turn a ketone back to an alcohol. It will turn an aldehyde back into an alcohol. It will turn a carboxylic acid all the way back to an alcohol. So the problem over here that with Q is that even this carboxylic acid will get reduced, and it will get reduced back to an alcohol. Is that clear?
Yeah.
So the thing is, so that's the wrong one. This is the right one. This is going to form this thing. Why? Because NaBH4, if you look at NaBH4, NaBH4 does the same thing as LiLH4, except for this one. It doesn't reduce carboxylic acids. Okay, carboxylic acids are not reduced. It's a slightly weaker oxidizing agent. So carboxylic acids are not going to get reduced. So NaBH4, if you use NaBH4, you'll get this, because this part will not get reduced, but the ketone part will get reduced. So the ketone part will turn back into an alcohol. So that's why. So the reasoning would be the same. Okay, you're going to talk about the strength of reducing agent, that NaBH4 is a milder reducing agent, and it will not reduce carboxylic acid. That's the basic answer. I mean, 1 mark for this one, R. You're going to write R, that's 1 mark. And the other mark is going to be that NaBH4 is a milder oxidizing agent, sorry, reducing agent, and it does not reduce the carboxylic acid. So moving to the next part, which is you've got this one, which is I mean, they're asking for, this is nucleophilic addition. So nucleophilic addition, and they're asking for identify the ion that reacts with propanol and draw the structure of the intermediate. So it's a cyanohydrin that's getting formed. So this question is nucleophilic addition. Just let me double check this one. I'm just checking through, confirming. Just 1 second. Where's the... that's fine. No issues there. So what's the mechanism for this one? You have to draw everything. Remember the mechanism. It's given over here. You have to, and remember, go through the mechanism and try and practice this. It should be exactly this way. You got a carbon which is positive. It's a polar bond. The Cn-1 is going to get attracted with its lone pair. Draw the lone pairs, and the double bond electrons are going to get repelled. So the first step of this mechanism would be, you draw, everything has to be exactly the same. You got a Cn-1 that's coming in. That's your nucleophile. That Cn-1 is interested in your electrons. The electrons in the double bond will be repelled. next step, what happens? You got a C2H5, and you got a C, and you got an H, and the O-1 is formed, and the CN bonds over here. Just 1 second. And the next step is you've got H+1 from the lone pairs are going to get attracted to the H+1 and they would form the alcohol. That's it. So just go through the mechanisms, make sure they're drawn exactly the same way. Every lone pair, every negative charge, every slight positive, slight negative, everything has to be exactly the way it is. And it's a 4-mark question. It's a big question. TK, remember, try and practice your mechanisms a lot and complete the equation now in step 2 when S is heated under reflux with HCl. So what happens with when you heat it with HCl or acid? You've got a
forms carboxylic.
TK, so that's given. TK, that's already given.
Ammonium
So
ion.
it's TK. So all you have to figure out is, as you got a nitrile and it's turning into a carboxylic acid. When you heat it with an acid, it could be any acid actually, not just sulfuric acid, but any acid, and reflux. So the question now is, what are the other two ions that are formed? What is it reacting with? It's reacting with HCl, right? And it's definitely going to form ammonium ions. The water gets added to the CN, it hydrolyzes, the N changes into ammonium ions, but you have to make a whole balanced equation. How would you do that? Ajay, this one, it's first thing about this question. It's really hard to memorize any of the organic equations. I mean, like no one is going to ask you to write an equation of K2Cr2O7 with an alcohol. Like it's going to be too difficult for you to memorize it. No one can memorize this. For example, if I write an equation or search for an equation of methanol with KMNO4, and I write an equation. So methanol, I mean, it's going to be a pretty long equation. It's almost impossible to actually memorize any of the organic equations. I mean, maybe it's given over here. Just a second. Just trying to find. Yeah, I can't. But anyways, you can Google this on your own. Any of the organic reactions, I mean, some of them are easy, like alkenes. The addition of water or bromine, that's easy. But the ones with KMNO4 and the ones where you have hydrolysis happening, that's slightly difficult to memorize all those equations. So you kind of have to, I mean, it's a 1-mark question, but you kind of have to make it on the spot. To try and balance this, what is hydrolysis? This is hydrolysis. Hydrolysis is a reaction with what? Which thing? Like how is, you've got CN and all of a sudden you have COOH. So where are all the oxygens and hydrogens coming from?
Water.
So remember, hydrolysis is a reaction with water. So there's going to be a lot of guesswork. And so now you've got a Cl over here. What do you do with the Cl? Because there's no Cl over here. So you got an ammonium ion, you got a Cl -1 over here. So probably it's going to be ammonium chloride, right? So that kind of, that's about it. That's the equation. That's and you just have to balance this. So how many water molecules? You got HCl, that's probably 1. How many water molecules? That's I guess
when you convert CN to COOH, don't you use H2SO4?
You can use any acid.
Oh, okay.
I mean, I mean, when you have hydrolysis, that applies to esters as well. Do you remember this? When you do hydrolysis, you have acidic hydrolysis and you have alkaline hydrolysis. So instead of NaOH, you could use KOH as well. Okay. Instead of H2SO4, you could use HCl as well. The same kind of applies to esters as well. You could use any acid for hydrolysis. Usually sulfuric acid is the cheaper one and NaOH is the cheaper one. I mean, it's a lot harder or expensive to make KOH. So that's why these two are often used. But it could be acidic hydrolysis or it could be alkaline hydrolysis. As I said, we kind of have, I think it's a balanced equation now. That's it. That's the 1 mark question. And then you have infrared spectroscopy. So you have 2-hydroxybutanoic acid. Deduce, so this one, the infrared spectrum of an organic compound is shown. The organic compound is either S or 2-hydroxybutanoic acid. Is either S. What is S? So S is this one. So S is a nitrile. That's and let me draw S over there. So S had a CN, it had a C2H5. And what else did it have? It had OH and H. So it had OH and it had H. And he's talking about the other compound, 2-hydroxybutanoic acid. So that's butanoic acid with double bond O and OH, and 2-hydroxy means the OH is on the second one. So which one is this? First thing, you're getting a strong absorption at this point. Okay, so you're getting a strong absorption at this point. So you'll open the data booklet, which would be given, and you'll go to the infrared spectroscopy, and there I think it's this one. So strong absorption in the 1040 and 1300 range. That's probably C single bond O. Okay, so this one is C single bond O. I mean, that's the only one I found, 1100 to 1300. But that C single bond O is in both of them. So I can't really tell which one is this. You got a C single bond O over here as well. And you got a C single bond O over here as well. So it could be both of them. So that is not helpful. Now the next one, you'll try and focus on the other one, which is this one. So somewhere around 3400. So when you get an absorption around 3400, that's if I open the data booklet. Now around 3400, I have absorptions when I have these ones. So it's these two. It's an alcohol, not a carboxylic one. It's an OH bond, but the one that belongs to an alcohol, because that's around 3400. It can't be a carboxylic acid OH, because that has an absorption around 2500 to 3000. So it's going to be this one. It's the normal alcohol. Okay, the amine can be left out because you don't have an N in this, so it's obviously not an amine. Nothing else is in the 3400 range. So that's a normal alcohol, whatever that is, but not a carboxylic acid OH. So you've got a normal alcohol OH. So that gets rid of this one. It can't be this one. It's probably going to be this one. Okay, is that clear? And and they're asking you to relevant absorption. So there's another one over here. It's got a CN over here as well. So I'm going to check where does CN. CN is in the 2200. It's a weak absorption around 2200. So if we go back, I've got a weak absorption. That must be CN. Okay, that must be CN. So that kind of
Sir,
confirms. So
if this peak tells you so strong,
which one?
the CN, it's sharp, right? Peak is sharp.
The peak is sharp, but it's also weak. I mean, they didn't. I say the reason the newer data booklet, it won't even have the description of the peak. So you'll just have. I mean, it's a weak peak. Weak means that it's a. I mean, this one is a strong peak. Remember the difference. This one is like a strong peak. This one is a weak peak. Is that clear? So, and he's only talking about above 1500. So you'll give two reasons. One of them is this one is an alcohol that belongs to a normal alcohol, and this one is a CN. So you're going to quote these two values. You're going to quote that at 2200 or whatever this value is. You're getting a CN, weak absorption, and at 3400 you're getting an alcohol, a normal alcohol OH bond. That's its absorption. So that confirms that it's this one. Is that clear? So we've got one more question to go. So we've got one more question. So I'll just quickly go through this. And we've got another, sorry, this is the same one. So it's about group 17. So Stan explained the trend in volatility. So what happens to volatility? Increases or decreases?
Decreases.
So they become less volatile down the group. Why? I mean, that's next part is explained. Why do they become less volatile?
Because they have got weak bonds.
Remember, this has nothing to do with the bonds. It has to do with the volatility is about melting and boiling. So melting and boiling has to do with the intermolecular forces. So
basically bond strength.
The intermolecular forces, it's van der Waals forces.
Right.
When you melt something, you don't break the bond. What you're doing is, like, if I change chlorine to gaseous, I'm breaking the attractive forces between the molecules. I'm not breaking the bond. Is that clear? So when I evaporate something, I'm not breaking the iodine bond. The iodine molecule is still intact. I'm just breaking the intermolecular force, which is van der Waals forces. So you're going to talk about them having, you're going to describe van der Waals forces as instantaneous dipole induced dipoles, attractive forces and interaction. And the strength of van der Waals forces, it increases down the group because you've got bigger molecules. You've got more electrons in the molecule. So you'll have bigger instantaneous dipole induced dipoles. Up bond strength wala aayega, the least thermally stable. Now, when you talk about thermal stability, now you're breaking the bond. So explain why HI, which one is more stable, HI or HCl?
HCl.
Is more stable, right? Or less
Yes,
stable?
HCl is stable.
HCl is more stable.
Yes.
Okay, so that's more stable. And HI over here on the other end is extremely unstable. So it's less stable. And the reason for that is that that you have a shorter bond length and there is a more orbital overlap, and the chlorine atom is less shielded, which is why it's attracting the hydrogen electron more strongly. So they only wanted, I mean, the first part was they already answered that HI is the least stable. You have to explain why is it unstable, because it's got a longer bond length and there's less orbital overlap. So you got a weaker bond, which breaks easily. Now the electronegativity values are given. So in terms of intermolec, why HI has a lower boiling point than HF? So what is happening in HF? Like, why is this having a higher boiling point?
Because it has a more electronegative attached to it.
Because it's going to form hydrogen bonds. Because the first thing is you're going to talk about the electronegativity difference. That's why they gave you this table over here. You're going to say that it's more polar. Okay, which is why it's going to form hydrogen bonds, and there's going to be more attractive forces between HF molecules. And HI is going to be less polar. It's 2.1 versus 2.5. So the polarity H is 2.1, iodine is 2.5. So although this is very, very slightly polar, so the dipoles or the permanent dipoles would be very weak. So it's going to have a lower boiling point. Iodine reacts with hot concentrated sodium hydroxide in the same way as chlorine. So what is going to be the reaction of iodine with NaOH and hot concentrated NaOH?
NaI plus NaIO3.
NaI plus NaIO3. I mean, the same with ClN plus water. And you remember to balance, I mean, you can either try and balance this, but remember the balancing as well for this one. That's given in the notes as well. And this is about iodoalkane can be made from methanol. Identify the reagents that can convert CH3. This is Idraform Test. So it's CH3. First thing, it's not an Idraform test. It's just how do you replace an OH with I, an alcohol with I?
P and I2.
Heat and I2, that's not heat and I2, it's
No, P phosphorus.
okay, so
No.
phosphorus plus I2 is fine, plus heat. You can also use HI plus heat as well. I mean, it's given over here. How do you convert an alcohol to a halogenoalkane? Red phosphorus plus I2 plus heat. You also use HI plus heat as well, but I mean, remembering one would be fine. And then the next one is this thing can be made by bubbling ethene into iodine. Name them. So what is the reaction mechanism for an alkene?
Electrophilic substitution.
The addition. It's going to be the same as bromination, electrophilic addition, which is this one. That you've got an alkene, and bromine is going to react with it, and in this case, he's saying iodine is reacting with it, so it's going to be the same mechanism, electrophilic addition. What is the name of this compound?
Two iodo, 2-methylbutane.
Okay, so the longest chain is 4 carbon atoms. That's butane. And remember, alphabetically name this. So the 2-iodo, that is alphabetically correct. So there's an iodine and there's a methyl on the second. So 2-iodo and 2-methylbutane. ठीक है, ये इस पे ना send me a WhatsApp on this. Okay, 1 second. As the next one, you've got fully name the mechanism of the reaction J with NaOH to form K. J reacts, so the halogen gets replaced by OH. So what is the name of the mechanism? A halogenoalkane.
Substitution.
And if I ask you to name the full name of the mechanism, I mean, it is nucleophilic substitution, but is it SN1 or SN2?
SN1.
Okay, because it's a tertiary halogenoalkane. So the mechanism is going to be SN1 for a tertiary halogenoalkane. The halogen will leave first and then the OH is going to come in. So it's going to be SN1. I've got this reaction NaOH in ethanol. Explain why L does not show Cistrons. Why does this not show cistrons? Simple explanation that the carbon in the double bond has the same groups attached to it on both sides. So it's not going to show that. L reacts with hot concentrated esterified KMnO4 to form propanone. And now this thing, hot concentrated KMnO4, it's an alkene, it's going to get oxidized. What is the first thing that will happen? The double bond between the carbons will break, right? What will this turn into? The one on the left.
Propanone.
Ketone.
Okay, that's going to turn into, this carbon will turn into, after the double bond breaks, it will turn into a ketone, which is this one. That the double bond will break. If it has 2 carbon chains, it will turn into a ketone. If it's got 1 carbon chain, it will turn into carboxylic acid. And if it's got no carbon chains, it's going to turn into carbon dioxide and H2O. So what happens to this other one? What will this turn into, this carbon over here?
Carboxylic acid.
Oxalate.
Okay, it's got 1 carbon chain. So this, this is the other carbon. So it's got only a carbon on one side. So it's going to turn into a carboxylic acid. That part is CH3 basically. So this carbon over here will turn into carboxylic acid. So identify the other product, that's ethanoic acid. Complete and balance the equation for this reaction. This one, probably slightly harder. You have to balance this one. And this is the Idraform test. What happens in the Idraform test is that if you have a CH3 with a ketone, with a CH3, what happens is that the CH3 will break off and it will form. In the Idraform test, it will form CHI3. So one of the product is going to be CHI3. That's going to be formed. What is the other product that's going to be formed in this reaction? The other product is given, that's already given. That's going to be the carboxylic acid. This carbon over here, it will turn into a carboxylic acid. But since the conditions are alkaline, it will form a salt of the carboxylic acid. So I've gotten these things over here. How do I balance this now? Okay, I've got a ketone. How many oxygens are getting added? That's 2 of them, right? The 3 over here as well. So now I need to balance this. So how many carbons? I should not change the carbons over here. So the hydrogens, let's try and balance the hydrogens. That's 3 plus 3, that's 6. How many hydrogens do I have over here? That's 3 plus 1, that's 4. That's 4, right? That's 4, and there are 2 hydrogens over here, and there's hydrogens over here as well. I just think how you can balance this equation. Okay, the OH is, ये वाला पहले कर लेते हैं 7, the last part. State 1 observation that can be made in the reaction. That is a yellow solid. It's a yellow precipitate is formed. CHI3 is a yellow precipitate. Now balancing this equation over here, how would you balance this equation? That's the question. Okay, how many iodines do you need in this case? And how are you going to balance this equation? So what is happening to the carbon over here? It's getting oxidized, right? So iodine reacts, and this one, we can use oxidation states, but we don't know what the oxidation state. So we can use oxidation state. Can you tell me what the oxidation state of carbon over here is? Okay, what's the oxidation state of carbon? kitna aa raha hai? Oxygen is -2, hydrogen is +1, right? So it's 3 carbons, that's 3x. Plus there's 1 carbon. But I don't want to do the. Let's go try and balance this the other way around. If I take 3i2, there's iodine. If I take 3i2, 3 of them react with the CH3 and they form, and there are 3i-1s left. In that case, I'll need how many water molecules? The water and the OH ions need to be balanced. I've got oxygens, 2 of them. As I'm just trying to figure out which atom should I start with, because it's going to be difficult. Just very quickly, just a second. Yeah, I'm not focusing on the other one. Focus on the oxygens first. Yeah, I'm trying to find the easiest way. I mean, this is CHI3, obviously. In the Idraform test, it's always CHI3. I'm just trying to focus on the easiest atom to balance. Focus on the oxygens. The oxygens are right now on this side, I've got 2 oxygens, right? As the first thing, I can't, like if I have 1 molecule, I'm going to get 1 CHI3 and 1 of this. So this is fixed. If I have 1 of this, I'm going to get 1 of this and 1 of this, right? So let's fix this. Because I know the reaction. I know the reaction that if I have 1 molecule of this, it's going to produce 1 CHI3 and it's going to produce 1 of this. This part will get oxidized to this thing. So I'm going to keep that fixed because I know that if I have 1 of this, it's going to be 1 of this and 1. So basically I need to balance the rest. Okay, because that part is already balanced. 1 molecule breaks down into 1 of this and 1 CHI3 is produced. So it's always going to be in 1:1. So I'm going to go for oxygen first. How many oxygens do I have on the left side? That's 2 oxygens. How many oxygens do I have on the right side? That's 3 oxygens. So I need to somehow keep the oxygens. Nika, how is it 2? Nidana, which one? Sorry. There's 1 oxygen over here. There's 1 oxygen over here. And over here, you've got 2 oxygens, and I've got 1 oxygen on this side. That's 3. Okay, so the oxygen is unbalanced. Yeah, at the moment, that's my starting point. That I've got 1 oxygen over here and 1 oxygen. Let me just recap. What I'm trying to do over here is, the problem with this balancing is, I can't use oxidation states. If I could use oxidation states, because the oxidation states are changing a lot in this question. So I can't really use oxidation states to balance this equation specifically. What we can do, by the way, is that we can kind of balance the charges in this case. That the number of charges, because the electrons are not being gained, or I mean, the overall, there is no electron showing up in the equation. So one thing that we can also do over here is that I can balance the number of charges over here. Okay, we can try 2 ways of doing this. The overall charge on this entire thing, if you add up the reactants, that's -1 at the moment, right? The overall charge on this side, that's -2. Like if I add up all the neutral molecules and everything, the overall charge on all the products together, that's -2, because you got a -1 over here, you got a -1 over here. So that kind of indicates that electrons are being gained, which you're not gaining electrons. There's no electron gain happening. They didn't write plus electron over here, so nothing is being gained. So the charges on both sides, they must be equal. So you can balance the number of charges. So I need to increase the charge over here. I need to make this higher. So what I can do is I can have 2OH -1. But even then we run into problem. We run into a problem, which is that the atoms are still not balanced. You got 3 oxygens. I think that is making so 3 oxygens over here. So the charges are now kind of balanced. So I've got 2 OH and I've got 1 H2O. The hydrogens are not balanced. How many hydrogens do you have? You've got 6 and you've got 2 of them, that's 8. Over here you've got 3 and 4. So the problem is it's not 8 hydrogens. I've got 8 hydrogens on this side. And I have to keep these things fixed. It's really hard to balance this one. Just one second. I have to keep these 3 things fixed. I can't change the ratio. One molecule produces one of this and one of this. So I can't change the ratio. And I have to keep the charges balanced on both sides. So I've got 8 hydrogens on the left side and I've got how many hydrogens? 4 hydrogens on this side, right? Is it 4? That's 3 plus 2, 5. I've got 6 hydrogens. So what I need to do now is I need to have 2 more hydrogens. So I'll make this 2 water molecules. So if I make this 2 water molecules, I now have 8 hydrogens. But the problem would be that the oxygen is not balanced anymore. I've got 1 oxygen and 3 oxygens, 2 oxygens over here. That's 3 oxygens, right? I've got 2 plus 2, 4 oxygens. So I need to increase the number of oxygens on this side. So if I increase the oxygens over here, that's if I make it 3 OH ions. So now the problem is that it's taking a really long time to balance this. Now, if I take this 3 oxygens, I have a total of 4 oxygens on this side, and I have a total of 4 oxygens on this side as well. But then the problem is, okay, I've got 4 oxygens and the hydrogens are not balanced. That's 3 plus 3, that's 9 hydrogens on this side. And over here I have 8 hydrogens. So I would have to increase the number of hydrogens on this side. So basically, it was the hydrogens. You can go on trying to balance the hydrogens and the oxygens. That's what's going to make the equation balanced. So if I take this as 3, now you have 6 plus 3, 9 plus 1, 10. You've got 10 hydrogens on this side. So I need to increase the number of hydrogens over here. 6 plus, that's going to be 4. Okay, now my hydrogens are balanced on both sides. I've got 10 hydrogens. And let's focus on the oxygens as well. Do I have the oxygens balanced? That's 1. Plus, 1 plus 4, that's 5. 2 plus 3, that's 5. So the oxygens are also balanced, 5 oxygens, right? Okay, so I think the key of balancing this equation was that you had 1 molecule and it would produce one of this, one of this. So you're going to keep the circled ones fixed. Don't change that. And try and balance the other ones. The next part is that the charges have to be balanced as well. So I've got 4 OH ions. That's a total charge of -4 on this side. Over here, I've got a -1 and I've got a -1. So I need -4 on this side as well because the electrons are not being gained or lost. So this would be 3i -1. Now the charges are balanced as well. You got -1 and you got 3i -1 over here as well. And the final thing is I'm going to focus on the iodines. That's 6. So that's going to be 3i2. Okay, now I think I finally been able to figure this out. So I'll just explain. Okay, one by one. Okay, this was pretty hard. This was very difficult. So I'm going to explain this once more. Okay, you started off. We know the Idraform test, right? They gave us the equation, the whole equation, which was pretty hard to balance. But one thing that I figured out initially was that if I have an Idraform test of this molecule, the CH3 will break off and it will produce a CHI3 yellow precipitate. That's what happens in an Idraform test. And this other part will break off and it will form a salt of the carboxylic acid. So one molecule will produce one of this and one of this. So that part of the equation was fixed. That was the first thing I decided, that I was not going to change this and this and this. Is that clear? That's the first part that I decided that I'm not going to touch that. The next part was that whenever you have an equation, since it is the overall equation, no one is gaining electrons or losing electrons. So I figured out that the total charge over here and the total charge on the other side, it must be equal, because no one is gaining electrons, no one is losing electrons. So the charges, they have to be balanced on both sides. I mean, that's another way of balancing redox equations. Like if I have this equation, Na plus 1 plus Al, okay, Na plus Al plus 3, and it's forming Na plus 1 plus Al plus 3. So that, I mean, this is Na and this is, sorry, 0. Now this one. So if I have this equation, it's a redox equation, but it's an unbalanced redox equation because the overall charge over here is plus 3. The overall charge, if you combine the two things, that is plus 1. So electrons gained and lost should be equal in an equation. If they're not equal, the electrons, they must show up in the equation, which they are not showing up in the equation. So Al plus 3 is gaining 3 electrons, and Na plus 1 goes to Na plus 1, it's losing 1 electron. So the Na must be multiplied by 3. That's how you balance the redox equation. The other way to check whether the equation is balanced or not is you total up the charges. What's the total charge over here on both ions together? That's plus 3. What's the total charge on both products together? That's plus 3 as well, because aluminium is 0. So since the equation had no electrons showing up, so whatever the charges, the total charges that you have over here, and whatever the total charges that you have on this side, they got to be equal. Like if you have -2 over here, you should have the total charges on the other side, they must be -2 as well. If it's not -2, then that means someone is gaining electrons and those electrons must show up in the equation. So that is one thing that I decided. That first thing I decided that this thing, and this thing, they must all be 1:1. The other thing was that the total charge on both sides must be kept the same. Only then will this be a balanced redox equation. The third thing was I started balancing the other atoms, ignoring these ones. These ones, I assumed that they were already balanced. So when I started balancing them, the problem was balancing the O and the H's. I started increasing the hydrogens on this side and then trying to balance the hydrogens on the other side. I kept on doing that just like the old-fashioned way. Eventually, a time came when the O's and the H's, they became the same on both sides. Once that happened when I had 4 OH ions and 3 H2Os. Then I checked whether the charges are the same on both sides or not. So I had to multiply this with the iodide with 3, because that's 3 negative charges and 1 negative charge over here. That's a total of 4 negative charges on the right side. And there were 4 negative charges on the left side as well. So the overall charges, if the number of electrons gained and lost are equal, the overall charge on this side and that side, it must be the same. So that was the final thing I did. But again, this was a really tough one. TK, it's a really tough one. That's how you're going to balance this. TK, is this clear?
Yes.
Yes, sir.
TK, just remember, I'm still trying to figure out, is there an easy way to do this? Probably not, because the problem is it's very hard to figure out the oxidation state of carbon over here. You can't figure out the oxidation state the old-fashioned way. That's ठीक है, वो मैं send कर देता हूँ. I'll send a few questions, but this one is pretty hard because you had to, because just balancing the oxygens and the hydrogens, that took a very long time. I mean, that was the simplest part. So anyways, that was kind of tough, even though it's a 2-mark question, but still tough. So and remember, you don't waste time. If you get a question like this, skip. If you have time left at the end, don't fret over questions like these. Make sure, keep in mind that there's probably, I think that's probably the hardest question I've actually seen. I mean, this one is really hard. That's what I'm saying. That's and it's just 2 marks. It's you'd probably get a 1 or 2 mark question on something similar to this. It's which is going to be extremely hard. Just don't fret over it too much. Don't waste I mean, keep that in mind. Just make sure that let's say 2 mark question, there might be some really tricky 2 mark question. So you can move on, do the rest of the paper, and then come back to this question. I mean, you'll probably get 1 mark for writing CHI3 anyways. So that leaves you with just 1 mark. So if you have time left, then I'll send that in the group chat. Okay? I have another class for A2 now. So I'll send questions, but remember, I've never actually seen a question this tough. So this one can be considered the toughest balancing equation questions. Alicia, can we do tomorrow? Take first thing I'll do recap mass spectroscopy. I mean, it's very simple. I'll do that. Take care. Okay then. Take care, Allah Hafiz.
Allah Hafiz.